All right, so now we are going to try for like the 30th time to make a video on simplifying square roots when there's variables underneath. So first, let's just recap. Guys, what's the square root of x squared? Just x, right? What is the square root of x to the fourth? X squared, right? What's the square root of x to the sixth? X to the third. Yes, right? So the square root of x to the eighth, Anthony, would be, there's the x to the fourth, right? Do you notice something going on here, people? What's that little tiny number that's out in front here that we don't actually write? There's a little tiny 2 there. There's a little tiny 2. Tiny 2, tiny 2, tiny 2. Let's jump ahead. Say I had the square root of, I don't know, x to the 24th. Oh, thanks. X to the 24th, that would be x to the 12th. So again, there's a little tiny 2. Do you notice some relationship between the, what was the vocab word for this number on the outside? Do you remember? Start with an I. What'd you say? Index. There's a relationship between the index and the exponent you get out. Do you see some relationship? They are all even in this case. Do you see something else going on? Yes, if you take your internal exponent and divide it by the index, you always get the answer that's back out here. Always. Always. 24 divided by 2 gets me 12. Okay? You're going to want to keep that in mind when we go to the cube roots and the fourth roots. Okay? So, we did talk yesterday about also when we need absolute value bars. Okay? When you need them, you follow the pattern. There's a little saying, even, even, odd. Okay? And here's what I'm checking. If the index is even and the exponent is even, but the exponent that came out is odd, that's when I need the absolute value bars. Okay? So the square root of x squared is actually the absolute value of x, and not just x. So we try this one. Even, 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 you don't need it. It's only when it's even, even, odd. Even, even, odd. Even, even, odd. Oops, I need it. Even, even, don't care. Even, even, don't care. So it's only for even, even odds. Okay? Now, we also talked about, yeah, well, what happens when you try and take a square root of an exponent that's not even? Well, that's where you get into some fancy math. So let's say I want to take the square root of x to the, I don't know, 13th. Well, x to the 13th is not a perfect square because it's not even, right? There is a teeny tiny 2 out here. 13 divided by 2 is not a whole number, though. So that's not really going to help me. What I need to do is I need to split this up. And when I'm taking a square root, I just want to think about the number closest to 13 without going over that is even. What is that number? 12. 12. So I'm just going to break it up into the square root of x to the 12th times the square root of x to the 1st. Isn't x to the 12th times x to the 1st x to the 13th? Yes. Isn't this a perfect square now? Isn't the square root of x to the 12th a perfect square? What is it? X to the 6th. And then I just keep that square root of x. Is that all right? It's this same process every single time with a square root. So with the square root, you always just drop it down 1 unit. So let's say I wanted to take the square root of x to the, I don't know, 9th. Well, 9's not even. So I split it up into the square root of x to the what and x to the what? X to the 8th and x to the 1st. What is the square root of x to the 8th? X to the 4th. And then that, you just leave it as it is. Does that make sense? Yep, Jared.
Could you do x to the 10th and x to the negative 1st?
What do you mean? Like if you wanted to do like that?
Like if it was x to the 9th.
Oh, I get what you're saying. X to the 9th and then split it up. You can. So do you get what he's saying? He's saying here, I split it up into 8 and 1 and I ended up with this. He's saying instead of doing 8 and 1, do 10 and negative 1. You can, but you're going to make it so much more complicated on yourself. But yes, you can do it. I'll show you real quick. You would have the square root of x to the 10th, and then the square root of x to the -1. Oh boy. Gosh, you're making it so much more complicated because now, that's x to the 5th, but then, remember an exponent of -1 really means 1 over x? Now you would have to simplify this and get the square root out of the denominator. Are you sure you want me to keep going? Because this is taking you down a road you don't want to go down.
Yeah.
That would be square root of 1, which is just 1, over the square root of x. So then you multiply by square root of x over square root of x. So now I've got x to the 5th times square root of x over x. But then I can simplify these two, right? If I have x to the 5th over x to the 1st, that's just x to the 4th root x. So yes, you can do it, but why would you ever? You wouldn't. So I got the same answer that I got this way, but way more steps. All right, so now what I would like to do is look at some of the ones on your homework. I'm going to end this video and hope that it recorded, and then we'll do a new one to go over the homework.